So friends, in this video we'll observe various waveforms. Okay, so one by one I will take you with the waveforms. I will display the waveforms on the DSO and you try to understand. Okay, so first section, as I have mentioned, is rectifier, where pulsating DCs are expected. So this is I am making the connections, so you can monitor the pulsating DC waveform over here. So you can see over here, so this is pulsating DC, and the peak voltage you can monitor here, okay, is 22.5. there is a small fluctuation that can be ignored. So 22.5 is the peak voltage that is recorded, that is required for subsequent calculation. Okay, now the second waveform I want to show is a capacitor voltage. You can see here, so I have connected this across, this is a reference, one and the same actually. So I have connected between this plus terminal of a capacitor and this is reference, and now I will vary this pot. You just monitor the DSO. Varying this pot, you can see the charging and discharging of the capacitor. So capacitor charges, it discharges, okay, charges, discharges. And if I will adjust this pot. By this pot, what I am doing actually, I am controlling the magnitude of the current through this capacitor. And what is the indication of this? You see the pattern of this charging, discharging. It is half, positive half, all positive halves. So actually this is related to your pulsating DC, and if you see, one specific level is maintained over here. So this is related to the Zener voltage actually. So Zener is used for voltage regulation, and that voltage regulation you can see here at the top, this curve is not there, it is a flat portion for this charging and discharging of the capacitor. And why this capacitor charges and discharges multiple times in one half? The reason is that, okay, this UJT has a specific peak voltage. The moment when the capacitor voltage reaches to peak, okay, this UJT turns on. The moment when this UJT turns on, okay, the charge on the capacitor discharges in a clockwise manner. I said clockwise manner, the current will flow. And when the current discharges, okay, current will flow through the primary of a pulse transformer, and due to the mutual inductance, okay, the pulses are coupled to the secondary as well, and we are getting the pulses, the same pulses as you can see, related to the charging and discharging of the capacitor. And what is the conclusion out of this? Pulses are produced during the discharging period of the capacitor. So that's all about the capacitor. Now I will show you some pulses as well. So see how I am making the connections here to show you the pulses. So this is reference, one and the same, and I will take you to the secondary of a pulse transformer. And my friends, now I request you to monitor the DSO. So what you are observing, some sort of spikes. Okay, these spikes are nothing but the pulses over here. So I will vary this pot now. Okay, I will vary the pot, and you can see the change in the pulses. So you can see the train of pulse actually. These are pulses actually. Okay, I will stop this. So these are pulses, is a train of pulse we are producing, which are applied to the thyristor. Okay, so I will adjust this. Okay, so you can see it very clearly what is the nature of the pulse. So this is actual nature of the pulse, and this pulse is produced during the discharge. And what we want to control actually, no doubt magnitude is fixed for the pulse, okay, but this duration on time of the pulse, okay, that has to be always greater than the turn on time of your SCR. Okay, and this time is being controlled. Okay, I will show you. This time is controlled by controlling the current through the capacitor. Yeah, you can see various pulses over here. So that's all. So in the next video now, we will observe the load voltage, we will set the different firing angles, and through that firing angles we can understand how SCR switching is controlled, and how average DC load voltage can also be controlled subsequently. Thank you very much.